Perfect Learn TV.
Hi! Welcome again to my video. So this is now the second part of our lesson about the laws of exponent. So for the first part, we have talked about the two laws of exponent, the exponent in algebra and the negative law of exponent. So today, we're going to continue our lesson about more properties of exponent. Are you ready? So here we are. Okay, so in the power of a power, we use this symbol. So we have a raised to m raised to n. And to simplify, this is the same as a raised to m n. As you can see, it shows an expression group inside the parentheses. So this is the group inside the parentheses. And this whole group is raised to n. So it is what we call the nesting situation. It tells that to simplify, we just multiply the exponents. Okay, so multiply m to the n so we can come up with a raised to n. So for example, we have x squared raised to 3. So, applying the law, we have x raised to 2 times 3. So, the answer is x raised to 6. Okay. So, to prove that x raised to 6 is the answer, let's have the extraction of the group. Okay. So, it says that x squared is going to multiply 3 times. So we have x squared times x squared times x squared. Okay? And for the next step, since x squared means we're going to multiply x 2 times. So we have x times another multiplication of the variable x 2 times x times x and another one x times x. So as you can see, we extracted the variables and we come up with 1, 2, 3, 4, 5, 6 x's.
3, 4, 5, 6 x's.
Daming excess naman yan, ma'am.
5, 6 x's.
Ano bang magmahal? Palagi bang nasasaktan?
And to simplify, we have x raised to. So that is the proof on how we come up with the law, the next law that we have discussed, or we have the law of a power of a power. Okay, easy, right? Okay,
Yeah.
so let's move with the next law of exponent. Is what do we call multiplying and dividing expressions with the same base but different exponents. Okay, so let's have a raised to m times a raised to n. As you can see, we have the same bases. So this is what do we call base. And this is exponent. Okay. So when we multiply the exponents or the expression having the same base but different exponent, we simplify this by adding the exponent. Okay, so write the base a and add the exponents. So this is what we call adding exponents. So for dividing expressions, we have a raised to m over a raised to n. Okay, so we have the same base a. So to simplify, since in the multiplication, in the operation of multiplication, we use the addition of exponent. So in here, in division, we do the inverse of the addition. So we use the subtraction of exponents. So we have m minus n. So this is subtracting exponents. As you can see, so multiplication is inverse of division and addition is inverse of subtraction. So they are the inverses of each other. So that is how easily you can remember or how easily you can master this laws. Okay, these two laws of exponent. So for example, in multiplying the same base but different in exponents, so we have 2 raised to 2 times 2 raised to 3. So as we can see, the bases are 2 and the exponents are 2 and 3. So the same base, different exponents. So applying the law, we have 2. When we have multiplication as the operation, we do addition of exponents. So we have 2 plus 3. Then simplify, we have 2 raised to 5. Okay, so to prove if 2 raised to 5 is really the answer, we also do, or we also can use the extraction, okay, of expressions. So it says that 2 raised to 2 means 2, we're going to multiply 2 twice. So 2 times 2. And 2 raised to 3, we're going to multiply 2 3 times. So we have 2 times 2 times 2. So how many 2's we have? 1, 2, 3, 4, 5. So therefore we have 2 raised to 5. So that's how the multiplication of the same base but different in exponent works. Okay, so next we have the dividing the expressions having the same base but different in exponents. So we have 2 raised to 3 divided by 2 raised to 2 as our example. So applying the law that I gave you before, when we use division as our operation, we do the subtraction of exponents. So we have 2 raised to 3 minus 2. So we have 2 raised to 1 or simply 2. Okay, so to prove, let's use again the extraction. No? So for the numerator, 2 raised to 3 means we're going to multiply 2 by 3 times. Okay, so for the denominator, we have 2 raised to 2. We're going to multiply 2 times. So in here, as you can see, we can use the cancellation method. Cancellation method is the crossing out the variables or the numbers that are the same in numerator and in denominator. So here we have 2 and 2, so we're going to cancel that, and also we have 2 and 2. The another one, so there's no more another 2, so therefore it's have a invisible one here. So we have 2 over 1. So this is the numbers that are left behind. So we have 2. So are they the same? So that's how the law of division, dividing the exponents or dividing the expression having the same base but different in exponents. Okay, so we're halfway there. So let's move again with our next law of exponent, and that is the dividing and multiplying the expressions with different bases but the same exponents. Okay, so let's have these expressions. So a times b raised to m, and we have a over b raised to m. So these are the last two laws that I'm going to give you. So this is what do we call multiplying, dividing expressions with different bases but the same exponent. So in here, I think this is the easiest law, okay? Because we only use the distributive property to rewrite the expression. So we're going to distribute the exponent to the variables. So we have a raised to m, b raised to m. So that's how easy it is. So for the division, distribute the exponent. We have a raised to m over a raised to n. So for reverse, we use the undistributive property. And we can also use the commutative property to express. So we have three methods, okay? So let's see how the commutative property works in this last two law. So let's say we have ab squared. Okay, so a multiplied by b raised to 2. So in commutative property, we're going to extract the group. Okay, so using the exponent, it simply says that ab is multiplied by ab 2 times. So we have a times b, another one, a times b. So in here, we're going to rearrange the variables so that we can easily see how to simplify it. Okay, so a and a, we have a times a and b and b. So b times b. So simplify, a times a is a square times b is b square. So that is the first one that I gave you. Second, for the division, no, the same process, the same method, but in division form. Okay, so we have a over b raised to 2. So we're going to multiply a over b 2 times. So a over b times a over b. So to simplify, we can combine these two by writing a times a over b times b. Then simplify. A times a is a square over b times b is b square. So we have the same answer, right? Okay, so we're now down to our last special property about our law of exponents. So let us consider an example of exponential expression. We have 2 raised to x is equal to 4. So solve for x. So how can we solve for x if the x is in the exponent? Okay, we're going to use the equation property. To solve for x, first, make the expression having the same base. So the expression here is 2 raised to x is equal to 4. So the bases are 2 and 4. So how can we make the bases the same? So let's have the solution. First, find the least common multiple of the bases. So our base is 2 and 4. And these 2 are multiples of 2. Right? Okay, so if they are multiples of 2, find the least common multiple. So to find it, we can use or we can list the multiples of 2. So we have 2, 4, 6, 8, 10, and so on and so on. Okay? So in here, the least common multiple is 2. Why? Because 2 and 4, this can be found here. Lowest number that we can acquire is 2. So therefore, our base is 2. So let us rewrite the expression. So we have 2 raised to x is equal to 2 as our base. Okay, next, we have now 2. Now, what number would be raised to 2 that is equal to 4?
2.
Okay,
2.
so you're right. We have 2. So 2 raised to 2 is 4. Okay? So if we have now the same base, we're down to our final stage in computing. So if they have now the same base, solve for x by copying the exponent into equation. Okay, so our exponent is x and 2, and for the equation we have, by writing it down, we have x is equal to 2. So it simply says that the value of x is 2. So want to check it? Okay, so to check, let's substitute the value of x into our exponential expression with the same base. Remember, you're going to substitute the value of x.
X na naman. Ayoko na siyang isipin, ma.
Paano bang magmahal? Palagi bang nasasaktan?
Only on the expression having the same base. Okay? So we have 2 raised to x is equal to 2 raised to 2. Substitute the value of x as 2. We have 2 raised to 2 is equal to 2 raised to 2. And this expression prove that they are the same and make the statement true. Okay, you got it? So this property is what will be called a raised to m, or can be illustrated as a raised to m is equal to a raised to n. But if and only if m is equal to n. So this special property is the most used property that you're going to apply by exponential functions because it simply says the equation. Okay, so we're going to equate the left side to the right side. Okay, so these are the basic ideas about the laws of exponent that will be applied in the exponential function. So to sum it up, here are the list of the laws of exponent. Let us review that the laws of exponent. First, a raised to 0 is equal to 1. Second one, a raised to 1 is equal to a. Third one, or the negative exponent, a raised to negative n is equal to 1 over a raised to n. For the fourth one, we have the multiplication of the same base but different in exponent. So to simplify this, we have a raised to m plus n. For the fifth, the division, we have a raised to m over b, a raised to n rather. So we have a raised to m minus n. For the sixth, we have different base but same exponent. We have a b raised to m is the same as a raised to m b raised to m. Next is the division. A over b raised to m is the same as a raised to m over b raised to m. And for our special property, a raised to m is equal to a raised to n if m is equal to m. So these are the laws of exponent. So that is the second part of my video, but hang in there because we still have the continuation of our topic for my next video. Before we end our session for today, I want to show my deepest gratitude for those friends who supported and still supporting our YouTube channel. And also, hello sa mga students ko, and especially to my advisory class. No, and
Keep safe, everyone. Have a good day.
Thank you for watching. Please subscribe to Perfect Learning TV for more videos and updates.